to the celebrated Achievers Mentorship Program, CHAMP. We're bringing academic dreams to reality. So in this video, we will be treating gas laws. Gas laws. So we'll just be treating the calculation aspect. So we'll be checking through all gas laws. So we have Boyle's law. We have Charles' law. We have Prayer law. We have the combined gas law, gas equation. We have the ideal gas equation. We have Dalton's law of partial pressure. We have Graham's law of rate of diffusion. We have Avogadro's law, and we have Gay-Lussac's law. So we'll be checking through these laws one after the other. In this video, I will be taking these first four. Then in the next video, I'll be taking these next three. Then in the last video, I will be taking this next two. So sit down with your book and pen. Click on the notification button to get more updates of other videos. Don't forget to like, share, and subscribe. Let's move on now. Boyle's law. Now in 1661, a man called Robert Boyles in 1661 determined the relationship between the volume and the pressure of a given mass of a gas. Volume and pressure of a fixed mass of a gas. So he concluded that the pressure of a fixed mass of a gas is inversely proportional to the volume, provided that the temperature is constant. Do you get it now? So I can say that P is equals to K over V. I can say K is equals to what? PV. Then I can say P1V1 is equals to P2V2. These are our formula for Boyle's law. Now, this is something you need to note. You may be let me explain what it means by this law. Pressure is inversely proportional to the volume. So that means as the pressure is increasing, volume is what? Volume is decreasing. Volume is decreasing. So now let me just give some representation to explain that before we launch into the calculation in depth. Yes, let's go now. Now Boyle's law. Now let's say we have something like this. Yes, let's say we have something like this, and we have a weight, maybe a stone placed on it. And this thing, it maintains this position, it maintains this volume. If I'm to ask you, if we replace this volume with this stone with something heavier, what will happen? If we replace it with something heavier, this thing will do what? Will come down. So we'll have something like this. This thing will come down because of this what? Because of this big weight. So that means when we increase the pressure increase. What happens to the volume? The volume what? Decrease. So when pressure increase, volume what? Volume decrease. Let's say we replace this one with a very small stone. We replace it with a very small stone, something like this. So this thing will do what? Will come up. To come up. So the volume will do what? The volume will increase. So as the pressure decreases, the volume will do what? The volume will increase. So never forget that. Never forget that. So what's the diagrammatic representation of Boyle's law? It's something like this. Diagrammatic representation of Boyle's law. So if the volume is very high, the pressure will be very low. As the volume is decreasing, the pressure is increasing. As the volume is decreasing, the pressure is increasing. And as the volume is minimum, the pressure is very what? Maximum. So yes, this is the diagrammatic representation of Boyle's law. So let's go to the graphical representation now. Graphical representation of Boyle's law. Yes, let's check it through now. Now let's say we have we said the volume is inversely proportional to what? To pressure. So if you have volume here and we have pressure here, it is what? It is inversely proportional. Inversely proportional. The same thing, you can have something like this: pressure, volume, inversely proportional. Or do you know, I can say, I say pressure is inversely proportional to volume. So I can say pressure is directly proportional to the inverse of the volume. So pressure is directly proportional to the inverse of the volume. Direct. The same thing, this volume, inverse of the pressure. Direct. Now if we now have something like this, maybe we say PV. with V. There is no relationship between the product of PV and V. So it will be what? No relationship. The same thing, PV, P, no relationship. Do you get it now? Yes. So don't forget your formula. P1V1 is equals to what? P2V2. So yes, let's take a question on that. But before we take a question, if they say your pressure is doubled, that means your P2 is equals to what? 2 times of P1. So if your P1 is what? P, your P2 will be what? 2P. If they say your pressure is tripled, or your volume is tripled, anyone, if your P1 is P, your P2 is what? 3P. If they say your volume or your pressure is what? Quadrupled, that means if your V1 is V, your V2 is what? 4V. The same thing, if they say your pressure is halved or your volume is halved, if your V1 is V, your P1 is P, your P2 is what? P over 2. If they say your volume or your pressure is what? Is quartered, your P1 is what? Your V1 volume is what? V, your V2 is what? V over 4. So these are the cases that they can give: doubled, tripled, quadrupled, halved, quartered. Yes, let's take questions now. And let me just talk on some other things. Yes. No, when we get there. So let's take the first question now. I will just dictate a given mass of a gas occupies a volume of 300 centimeter cube at 900 millimeter mercury pressure. Calculate the volume occupied by the same gas at 750 millimeter mercury if the temperature is held constant. Yeah, so let's treat this now. So yes, what's the solution? Yes, we have a volume of 300 centimeter cube, occupy a volume of 300 centimeter cube. That's your V1, 300 centimeter cube. At 900 millimeter mercury, P1, 900 millimeter mercury. Calculate the volume occupied by the same gas at 750 millimeter mercury. Calculate the volume, V2. At 750 millimeter mercury, P2, 750 millimeter mercury. If the temperature is what? Held constant. So what's your formula? P1 V1 is equals to what? P2 V2. What's your P1? 900. What's your V1? 300. What's your P2? 750. What's your V2? So you divide both sides by what? 750. Yes, let's solve it now. V2 is equals to what? This one cancels this one. 75 in 300 is what? 4. 90 times 4 is what? 360 centimeter cube. As simple as that. Let's move on now. The next one. Okay, let's just take some questions that are related to Boyle's law alone in Lamlad. So with that we can move on. So let's go now. Yeah, let's move. So we have the first question here. The mathematical representation of Boyle's law is, yes, that's what volume is inversely proportional to pressure, temperature is constant. Yes, let's move on now. Okay, this volume and temperature, that's not Boyle's law. Let's move on. As the pressure of a gas increase, there will be a decrease in what? Pressure increase, there will decrease in what? Volume. That's Boyle's law. Let's take this next question. If the pressure of 200 centimeter cube of a gas is halved, so it's very simple. Just solve it. This 200 centimeter cube is what? Is the volume. So volume is what? V1, 200 centimeter cube. They said the pressure is halved. What did I tell you? If pressure is halved, P1 is P. P2 will be what? P over 2. Do you get it now? They said what will be his new volume? V2 is equals to what? So solve it. P1 V1 is equals to what? P2 V2. What's P1? P. What's V1? 200. What's P2? P over 2. What's V2? That's what you are looking for. This P will cancel this P. V2 is equals to what? 200 times 2. V2 is equals to what? 400 centimeter cube. Do you get it now? Let's move on. Question. Let me check for other questions on pressure. Yes. I'm coming. Okay, yes. So once we are done other questions, we'll come back to this. But I believe you get prayer now. Yeah. Yes. Let's check Charles law now. Charles law. Now, yes. After Boyle's law, we have a man called Jack Walsh. Charles. No one will ask you the full name. Don't mind me. Find the relationship between the volume and the temperature of a given mass of a gas at constant pressure. Pressure is constant. So what was he saying? He said the volume of a given mass of a gas is inversely proportional to the absolute temperature. Please, this must be there. Absolute temperature. What did he mean by absolute temperature? It means that the temperature must be in what? In Kelvin. The temperature cannot be in degrees Celsius. And how do you convert from Celsius to Kelvin? This is it. Just add what? Add 273. It will give you what? Temperature in Kelvin. So let's say you have 27 degrees Celsius. To Kelvin, add 273, 300. You have 37 degrees Celsius. To Kelvin, add 273, 310. These are the past common values that JAMB use. I still remember. You have 87 degrees Celsius, add 273, 360, and all of that. It may not be perfect numbers like this. They can give you anything at random. They can give you 53 degrees Celsius plus 273. So that will give you what? That will give you 3 to what? 3 to 6. Yeah. So that's just that. That's just that. So that's how to get the curl. Yes. So what was he saying? He said it's directly proportional to its temperature in what? In Kelvin. So this is it. Directly proportional. Sorry. Yeah. So let's solve it now. So you have what? We have V is equals to what? KT. Make K the subject. K is equals to V over T. So V over T is a constant. So we have V1 over T1 is equals to V2 over T2. Yes. So this Charles law. This Charles law. This Charles law. Yeah. Let's move on now. Now, let me give the diagrammatical representation. Yes. As the volume is increasing, the temperature is what? Increasing. So you can have something like this. So when the volume is small, the temperature is small. When the volume is increasing, the temperature is increasing. Volume is increasing, temperature is increasing. Volume is increasing, temperature is increasing. Do you get it now? Yes. So volume and temperature, they are directly proportional. They're directly proportional. Yes. That's just about volume and temperature. Let's keep moving. Yes. Then we say we've talked on the diagrammatic representation. Let's quickly check the graphical representation. Graphical representation. Yes, this is it. Volume and what? Temperature. If this temperature is in Kelvin, please check your graphs very well. If this temperature is in Kelvin, it will be a straight line graph. But if the temperature is in degrees Celsius, it will be like this. This point is your what? Is your 0 Kelvin, because it must start from what? 0 Kelvin. But because this is the Celsius, so this 0 Kelvin is the same thing as what? Minus 273 degrees Celsius. Minus 273 degrees Celsius. So please take note of it. If it's cut at if the intercept is not at 0, yeah, it is what? Degrees Celsius. But if it starts from the origin, that's what? Kelvin. Do you get it now? Yeah. Let's move on. So that's the representation of what? Charles law. Charles law. Yes. So I believe we can begin to take questions on that now. So yes, let's take the first question I have with me here. They said at 22 degrees Celsius, a given mass of a gas occupied a volume of 250 centimeter cube. What is the volume of the gas at standard temperature if the pressure is constant? Now, let me quickly talk on standard temperature and pressure. Now, this is it. If they say something is at standard temperature, that means the temperature is what? 273 Kelvin. So standard temperature is what? 273 Kelvin. If they give you standard pressure is what? 760 millimeter mercury, or what? 1 atm. This was standard pressure. So let's solve it now. At 22 degrees Celsius, that's your what? Temperature 1, T1. But I told you that it can't be in degrees Celsius. You have to add what? Add 273. That's what? 295 Kelvin. A given mass of a gas occupied a volume of 250 centimeter cube. V1 is what? 250. What's the volume of the gas? V2. At what? At standard temperature. What's your T2? Standard temperature. T2 is the same thing as standard temperature. That's what 273 Kelvin. What's the formula? V1 over T1 is equals to V2 over T2. What's V1? V1 is what? 250. What's T1? 295. What's V2? That's what you are looking for. What's T2? 273. So just multiply. V2 is equals to what? 273 times 250 over what? 295. So you can just press it. You will get what? 231 centimeter cube. Yeah, let's move on. Let's take the questions on lambda that is related to temperature now. Let's move. Yes. So we have our first question. Yes, they said the above diagram is the graphical representation of what? You have volume, you have temperature. Starting from 0 Kelvin. That's what Charles law. Charles law. Yes, let's come here. Yes, they said I'm coming. Let's get a calculation question on okay. This is it. What's the temperature? What's the temperature of a given mass of a gas initially at 15 degrees Celsius? Oh, okay. This is Boyle law. I'm sorry. This is Boyle law. Yeah. Let's take question 18. Question 18. The temperature of a gas is 37 degrees Celsius. T1. 37 degrees Celsius. Then at what temperature? At what temperature? T2. That's what you're looking for. Will this original volume be halved? Oh, this general gas law. I'm coming. Let me just be patient. Or maybe we can just treat general gas law straight so that we aren't just wasting time. Yes, all the questions here are general gas law actually. Yes, so we can just move on. Let me just move on yes, let me just move on with my general gas law. Yes, general gas law is derived from two things, from two laws. We have the what? Boyles law. This is a jam question. Boyles law and what? And Charles law. General gas law is derived from Boyles law and Charles law. So if you have, what's Boyles law? Boyles law is what? V is inversely proportional to pressure. What's Charles law? V is directly proportional to temperature. So if I mix them together, I can have something like this. V is equals to KT over P. Vp is equals to KT. Vp over T is equals to what? K. Yeah. So we have what is equals to K. So V1 P1 over T1 is equals to what? V2 P2 over T2. This is the general gas equation. V1 P1 over T1 is equals to what? V2 P2 over T2. Yes, let's move on now. So this formula is really important. And don't forget, if something is halved, if P1 is P, next one will be what? P over 2. Yes. If the temperature is tripled, if P1 is if T1 is T, T2 will be 30. Yeah, so let's check the other one. Yes, let me just treat prayer law. Prayer law is just if you take P1 over T1 is equals to P2 over T2. Yes, so I just treat all the laws now. Like I just revisit all the laws, then we'll begin to take questions. Yes, what's the first one? P1 V1 is equals to P2 V2 or V1 P1, anyone. Then you have Charles law. V1 over T1 is equals to what? V2 over T2. Then you have the next one. V1 P1 over T1 is equals to V2 P2 over T2. Then you have the next one. P1 over T1 is equals to P2 over T2. Please take note of this 4 very well. Take note of this 4 very well. Yes, let's move on now. Now let's take the first one. We have okay, let's take questions. We'll just be taking general questions on them. So we have the first question here. What is the temperature of a gas initially at 15 degrees Celsius? Volume. We get okay. What's the temperature of a gas? Okay, initially at 15 degrees Celsius. So the temperature was initially at 15 degrees Celsius. T1 is what? 15 degrees Celsius plus 273. That will give you what? 288 Kelvin. And 18 atm. Atm is what? Your pressure. 18 atm. If the pressure is reduced to 6 atm at constant volume, so this is your pressure loss. So you have what's the temperature? T2. So you have P1, you have T1, you have P2, you have T2. Which law relates that? That's what? P1 over T1 is equals to P2 over T2. What's P1? 18 over what's T1? 288. What's P2? 6. What's T2? That's what you're looking for. So you can just continue. You have 6 times 2, 8, 8, all over what? All over 18. So that will give you what? 6 and 1, 6 and 18, 3. So you can just divide. We have 3 and 28. That's what? 9. Then 1. That's what? 96 Kelvin. 96 Kelvin. That's option C. That's option C. Next one. Next one. Yes. They said a gas occupying an initial volume of 2 dm cube. Initial volume 2 dm cube. Yeah. V1 2 dm cube is heated and allowed to expand to 6 dm cube. Heated allowed to expand to 6 dm cube. So your V2 is what? 6 dm cube at constant pressure. So the pressure is constant. They said the ratio of the initial to the final is what? So this is just it. You have Charles law here. V1 over T1 is equals to what? V2 over T2. What's V1? 2 over T1 is equals to what's V2 over, V2 is 6 over what? T2. You need the ratio of T1 to T2. Yes, 2 here 1, 2 in 6, 3. So cross multiply, you have T2 is equals to 1 times T2, that's T2, is equals to 3 T1. And you need T1 ratio T2. Just do something like this. T1 over T2, that's T1 ratio T2 is equals to, yes, what we multiply with T2, that's what? 1. That's 1 over what we multiply with T1, the coefficient T1, that's what? 3. So the answer is what? 1 ratio 3. Please be wary, it's not 3 ratio 1, it is 1 ratio 3. I hope you know how I got that. What we meet T1, this is it, T1, that's 3, T2 is what? 1. So that's 1 ratio 3. Next question now. The temperature of a gas is 37 degrees Celsius. So the next question, the temperature of a gas is 37 degrees Celsius. Yes. So your T1 is equals to what? 37 degrees Celsius. So change it to Kelvin plus 273. That's what? 310. Yes. At what temperature? T2. That's what you are looking for. Would its original volume be halved? They said you want to halve the original volume. So I told you about halve. That's what V. If V1 is V, V2 will be what? V over 2. Are you following? Why the pressure is what? Quadrupled. So you want to quadruple the pressure. That's what? 4P. So P1 is P. P2 is what? 4P. So let's solve it now. So you have T, you have V, you have P. What's your formula? V1 P1 over what? Over T1 is equals to V2 P2 over T2. What's V1? V, right? What's P1? P over what's T1? 310. What's V2? V over 2 times what's P2? 4P all over T2. T2 is what? That's what you are looking for. So let's quote. V cancels V, P cancels P, right? So you have 4 here. 2 here 1, 2 in 4, 2. So cross multiply. T is equals to what? 2 times 310. T is equals to what? 620 Kelvin. So that's the answer. That's option C. Next question. From which of the following laws is general gas equation derived? That's what? Boyles law and Charles law. Boyles law and Charles law. Yes, question 20 now. Yes, question 20. The pressure of a gas. That's what? The pressure of a gas that occupies a volume of 600 centimeter cube. V1, 600 centimeter cube. At 87 degrees Celsius. That's what's your temperature. 87 degrees Celsius plus 273. That's what? 360 Kelvin. Is 900 millimeter mercury. Millimeter mercury is your what? Pressure. P1 is 900 millimeter mercury. He said, what is the pressure of the gas at minus 33 degrees Celsius? So what is the pressure? What is the pressure at minus 33 degrees Celsius? Minus 33 degrees Celsius. So minus 33 plus what? Plus 273. That's what? 240 Kelvin. Then if the volume is reduced to 300 centimeter cube, which is what? 300 centimeter cube. So yes, what's your formula? V1 P1 over T1 is equals to V2 P2 over T2. What's V1? 600. What's P1? 900. What's T1? 360. What's V2? V2 is 300. What's P2? Then what's T2? 240. So yes, let's solve. 12 in 24, that's 2. 12 in 36, that's what? 3. Then we have don't be bothered about my cutting. 3 in 900, that's what 300. 300 in 300, so it cancels out. Pitch is equals to 600 millimeter mercury. I'm actually doing the cutting like this because you may not be entitled to calculator when you're doing your calculation in the exam. And yes, because it may be slow, the calculator provided is not a very big calculator, and yes, so you can still use it if you know you can make a mistake. Let's take the next one now. A gas occupies a volume of 0.75 dm cube. So volume 0.75 dm cube at 27 degrees Celsius, T1, 27 degrees Celsius, that's what 300 Kelvin, and 0.98 mm, P1, 0.98 cm. The volume of the gas at 75 degrees Celsius, so they said volume is 75 degrees Celsius, that's what temperature plus 273. That will give you what? That will give you 358. Let me confirm. Yeah. So this is 278 plus 7. That's 348. Sorry. 348. Yes, let's move on. And 0.98 cm. P2 is equal what? 0.98 cm. Yeah. So let's solve it. V1 P1 over T1 is equals to V2 P2 over T2. It should actually be V1 over T1. Let me tell you the reason. Because the pressure is not changing. The prayer is not changing, but any formula you get your answer. P1 is what? 0.75. P1 is what? 0.9. T1 is what? 300. V2 is what? That's what you are looking for. P2 is what? 0.9. T2 is what? 348. So 0.9 cancels 0.8. So you have V2, which is what? 0.75 over 300 times what? Times 348. So V2 is, yeah. Let's try to do this one. So if I am to solve this question without a calculator, I'll just do something like 0.75 is what? Is 3 over 4. Then times 1 over 300 times 348. So yes, from here 3 in 300, that's what? 100. 4 in 348, that's what? 87. So which is what? 87 over 100, that's 0.87 dm cube. But you can press calculator, you can just press it from here. Anyone will get your answer. Let's try another question now. Next question, question 22. The gas initially at 273 Kelvin, that's what? T1. Now you don't need to add 273 because it's in Kelvin already. Is it such that its volume and pressure becomes twice the original volume? So volume becomes twice. So if V1 is V, the volume is now twice. So V2 is what? 2V. Just like you are doubling it. Then if P1 is P, the volume and the pressure become twice. So P2 is also what? 2P. So put it into your formula. They said what's the new temperature? T2 is what? So V1 P1 over T1 is equals to V2 P2 over T2. What's V1? V. What's P1? P. What's T1? 273. What's V2? 2V. What's P2? 2P. What's T2? 273. Cut. Cancel. So you have what? 1 over 273 is equals to 2 times 2, that's what? 4 over, oh, we are looking for T2, I'm sorry. So this is T2. 4 over T2. So cross multiply. T2 is equals to what? 4 times 273. If you press it, you are going to get what? 1092 Kelvin. Next question. The pressure exerted by 50 centimeter cube of oxygen is 500 millimeter cube. Yeah, so volume 50 centimeter cube. The pressure is what? 500 millimeter mercury. What will be the new volume? V2. If the pressure increases to 750 millimeter mercury, pressure increases to 750 millimeter mercury without changing the temperature. So we aren't changing temperature. This is what Boyles law. V1 P1 is equals to V2 P2. That's what? 50 times what's P1? 500 is equals to what's V2 times what's P2? 750. So 50 times 500. So just divide both sides by this 750 divided by 750 divided by 750. So 250 here, that's 3. 250 here, that's what? That's 2. So V2 is equals to 100 over 3. V2 is equals to 33.3 centimeter cube. Yeah, let's move on now. I think I have 2 more questions on the loss we've treated. A gas occupies 75 dm cube. That's question 25. A gas occupies 75 dm cube. So volume is what? 75 dm cube. At STP, what's the meaning of STP? So your T1 will be what? ST. That's what? 273 Kelvin. Your P1 is what? SP. They say that STP. So this 75 dm cube is at STP. So we have standard pressure. That's what? 760 millimeter mercury. They said, what would it occupy at 27 degrees Celsius? So T2 is what? 27 degrees Celsius. Convert it to Kelvin. Plus 273. That's what? 300 Kelvin. Yes. At 300 and 950 millimeter mercury. So pressure is what? 950 millimeter mercury. So yes, let's solve it now. So we have what? V1 P1 over T1 is equals to V2 P2 over T2. What's V1? V1 is what? 75. P1 is what? 760. T1 is what? 273. V2 is what? V2 is what we are looking for. They said, what's the volume? What will it be? Yes, so V2 is what we are looking for. Then what's P2? 950 over what's T2? T2 is 300. So let's solve it now. V2 is equals to 75 times 760 times 300 over what? Over 950 times 273. So yes, let's just quote. So what should we divide straight? Yes, anyone. Yes, we can actually say this one cancel this one. 3 in here, 100. 3 in 273. That's what? 91. Then you can use. So yes, what will be your V2? So if you try to multiply, you should get what? 65.9 dm cube. Multiply that of the top, multiply that of the bottom, and divide. Yeah. So that's 65.9 dm cube. Let's move on now. Yes, let's go to question 26. Yes, which is the last question under the laws we've treated for now. They said a gas occupies a volume of 200 centimeter cube. V1 200 centimeter cube. Then at 18 degrees Celsius, T1 18 degrees Celsius. Convert it to Kelvin. That's what? 291 Kelvin. And 0.9 atm. P1 0.9 atm. No, that this is what? ATM. So yes, they said its volume at STP is what? So STP. So that is T2 is equals to what? ST. What's ST? 273 Kelvin. P2 is equals to what? SP. What's SP? I said SP can be what? 760 millimeter mercury or what? 1 atm. But because our unit here is atm, so our SP would be what? Would be 1 atm. So what's V1 P1 over T1 is equals to V2 P2 over T2. Yes, please, if you are having problem with understanding, you can just play back. So what's our V1? Our V1 is what? 200. Then our P1 is what? 0.9. Our T1 is what? 291. Our V2 is what? That's what we are looking for. Our P2 is what? 1. Our T2 is what? 273. So yes, just try to multiply. V2 is equals to 200 times 0.9 times 273 over 291. So what's the answer? Yes. Should I try it out? Okay, that should give me. Let me just press my calculator. So yes, at the top I have 49140 divided by 291. Yes, this should give me. This is not up to 2. This is 1. Yes, okay. Let me just press it. 168.86. So that's approximately 169 centimeter cube. That's option A. So yes, we are done with the first 4 laws that we say we will be treating. Boyles done, Charles done, then general gas law done, and pressure law done. Yes, you can just go through it and try to solve as many questions as possible on these laws that we've treated. Yeah. Now, just watch out for the next video. In the next video, we'll be treating the other laws, which are ideal gas law, Dalton's law, and Graham's law. Then the last video will be for Avogadro's and Gay-Lussac's law. Thanks so much for staying through to the end. This is the celebrated Achievers Mentorship Program, Champ. We're bringing academic dreams to reality.